Hey guys, Dr. Brown here, and tonight we're talking about ellipses. So this is a pre-calculus class, or anybody that wants to check out some cool stuff with ellipses. We're going to derive in this video the formula for an ellipse, and then in future videos we're going to dig into usage of that. So I'm kind of big into, well, where did they get that formula? And it's kind of cool to try to figure it out. Okay, I have something over here that, if you can imagine in your mind, is an ellipse. It looks like a warped football, but nevertheless, that's what we have. Let's see if I can get around here. All right, so just like when we studied in parabolas, we have a focus. So in this case, though, with an ellipse, you have two of them. So you have a focus here. I've listed as F1. And then this focus, which was F2. So you also have a vertex here, and it's a distance from the 0, 0 point here along the x-axis. And then you have another vertex at negative a, same distance. Just like this point of the focus is at negative c, this focus is at positive c, 0, along the x-axis. But one of the cool things about ellipses is this, and this is kind of cool if you think about drawing an ellipse. If you had a thumbtack here and a thumbtack there, and then a string tied around your marker, and it could swivel around, you could keep the string taut, keep it tight, and it would allow you to draw that ellipse as that string goes around. So what that is telling you is that this distance plus that distance equals 2a. Okay, so we have the distance from P to F1, plus the distance from P to F2, that equals 2a. Now we could say, well, let me just say the distance from PF2 equals 2a minus the distance from PF1. Okay, I could say that. Well, what is the distance from PF2, from P to F2? Well, we would have x minus c, and we know how to do this in what we've done before with circles and parabolas as well. A distance from 2 points would be x minus c squared plus y minus 0 squared, which is just y squared. Okay, that equals 2a minus the square root of x minus a minus c, because this is at negative c, so x minus c would be x plus c squared plus y minus 0 squared, which is y squared. Okay, so now I have these radicals here. Let me square both sides. So this radical drops, so I would have x minus c squared plus y squared, and that equals, I may scoot over to give myself a little more room. So I have 2a times 2a would give me 4a squared minus two of these guys. Well, it would be 2a times that, so you'd end up with 4 of them minus 4a times the square root of x plus c squared plus y squared. And then the outer times outer would be this times itself. So a negative that times a negative that gives you a positive without the radical sign, plus x plus c squared plus y squared. Well, let's see what to do. Okay, we've got a y squared. If I subtract y squared from both sides, that cancels. Well, and this is a x minus c, that's x plus c. So let me expand those and see what happens here. So taking this times itself, so x times x is x squared minus 2cx plus c squared equals 4a squared minus 4a times all this stuff under the radical sign, x plus c squared, hopefully you can still see that, plus y squared, plus, let's expand this, that's x squared plus 2cx plus c squared. And we've already subtracted that guy out. Okay, so I can subtract c squared from both sides. What else can we do here? Oh, we can get rid of the x squared, get rid of that guy, subtract it out of both sides. So now that leaves me with negative 2cx equals 4a squared minus 4a times the square root of this guy, x plus c squared plus y squared plus 2cx. Well, all right, let's add 2cx to both sides, and then I'm going to subtract this from both sides. So that would give me 4a squared. Remember, this is going to go to the other side. I better put it there. 4a times the square root of x plus c squared. I'm writing at an odd angle here, so bear with me. Hopefully the writing is not running downhill. All right, that's all under the radical. 4a, so I've added that. And I'm going to add this to both sides, so that would give me plus 4cx. So I had two of them here, I add 2 to this 2, gives me 4. Now then, I'm going to divide everything by 4. So I end up with a times the square root, so that was divided by 4, divided by 4, divided by 4, a times x plus c squared plus y squared, and that equals a squared plus cx. All right, now then, we're going to take this over there. So let's just start about here, I guess. So I'm just going to bring that up. So I've got a times square root of x plus c squared plus y squared. That's all under the radical. And that equals a squared plus cx. All right, we're going to square both sides. So I'm going to do this with it, because I'm trying to get rid of that radical sign there. All right, so I end up with a squared times that under the radical. And that equals, so now I have this times itself. So I would have a squared plus cx times a squared plus cx. I'll write that down so we can see it. A squared times a squared is a to the 4th. Outer times outer would be plus a squared cx. And then on the inside you have a squared cx. So I have two of those. 2a squared cx plus c squared x squared, because you're multiplying those two together, plus c squared x squared. Okay, clean up a little bit here. Now let me multiply this to the inside. I've got a squared times x. Oh, excuse me, I've got to expand that, don't I? All right, let's expand that. So now I have x plus c squared gives me x squared plus 2cx plus c squared, and that's plus this y squared, and all of that's times a squared, and that equals a to the 4th plus 2a squared cx plus c squared x squared. Whoa. Okay, now then, Let's distribute the a squared to the inside. We have a squared x squared, and then a squared times 2cx gives me 2a squared cx plus a squared times c squared. Couldn't read my own writing there. A squared c squared plus a squared y squared, and that equals a to the fourth plus 2a squared cx plus c squared x squared. Man, what to do with that? Well, I could subtract 2a squared cx from both sides. That would cancel those. I have a x squared term here. I'm going to move it over with this guy. I have an x squared term here, which would give me a squared x squared minus c squared x squared. So that got rid of that one. Let's see, what else can we do? Let me subtract a squared c squared from this side and move it over here. So that's a to the fourth minus a squared c squared. So plus a squared y squared. So that gets all the terms. All right, now then, let's factor out of this the x squared. So I have a squared minus c squared times x squared plus a squared y squared, and that equals, I'll factor an a squared out of this, a squared minus c squared. Whoa, now it's shaping up. Now then, I'm going to divide both sides by a squared times a squared minus c squared. Okay, so I'm going to divide this by a squared minus c squared. Well, it's a squared times that. And this one, a squared divided by a squared minus c squared. Now you'll notice this one, the a squared minus c squared over itself, that divides out to be 1, and I'm left with x squared over a squared. Plus, and this one, the a squares cancel, and I'm left with y squared over a squared minus c squared. Now for convention's sake, what they did, they said, well, we're going to let b squared equal a squared minus c squared. Now that means, if you do that, that b squared plus c squared equals a squared. So it's telling you that b squared, or excuse me, a squared is greater than b squared. If that's the case, a is greater than b. Okay, so a would be this on the major axis. B, you'll see we're going up here to point B, that's the minor axis. So anytime you're doing the calculations, find the larger number and set that equal to the a value, or a squared actually if it's in the denominator. Okay, so if we set b squared equal a squared minus c squared, we're left with a squared divided, x squared divided by a squared plus y squared divided by b squared. Equal, we didn't do this side, did we? All of that divides out to be 1. So that's where the equation for an ellipse comes from. X squared over a squared plus y squared over b squared equals 1. Now if, and again, a is the larger of, a squared is the larger of the two numbers that you end up with. And that defines the major axis. It could be turned up like this. I mean, it could look like this. And if that's the case, then the y value obviously is the larger number, or the b. The b in that would be your larger number. excuse me, A would end up being here. So this formula for this one would look like x squared over b squared plus, so x squared over b squared plus y squared over a squared equals 1. A is always the larger number. So you would just transform the formula like this if you had this situation where the major axis was along the y. In this case, the major axis is along the x, so the a term is under the x value. In this case, the a is under the y value. Okay. Why are we doing this? I think we're crazy. No, we're trying to build a better tomorrow and do that together and do it through math, okay? Now I have a little saying at the bottom. I heard this with a professional football team. One of the quarterbacks one time, he said, "We do not rise to the situation. Rather, we sink to our level of preparation. And that's why we prepare, we prepare, we prepare." Now, how do we prepare? We prepare doing these types of things, trying to expand our mind, get a deeper understanding of mathematics. Okay, hopefully this helps. And then in the next video, we'll work through how we use those equations to study ellipses. All right, that's all for now, and we'll talk to you next time. Thanks.